Hey, Pre-Calc students, Mr. Mitchell here. We're going to continue with finding zeros, section 2.5. So we're finding real zeros, and we're given an imaginary zero. It's a complex zero. So along with this, we also know that 1 minus 3i is a zero as well. They come in conjugate pairs. So you've got a couple different ways you can approach this. You could find the polynomial created by these two, and then do long division, and then solve that remaining polynomial. Or you could do synthetic division. You might say, well, how do we do that? I'm going to show you how to do synthetic division with imaginaries, or you could also do it with square roots. So let's go with synthetic division. So we have 1, -3, 6, 2, and -60. So there are no spaces missing. So 4, 3, 2, 1, 0 powers. We just need to be careful, make sure we give ourselves enough space. So bring down the 1, multiply this first one. The multiplication is fairly simple. Add that column, you're going to get -2 plus 3i. Remember, you can only add things together that are the same. So now we're going to multiply this times that. Now that multiplication, we may need to write that down. So you're going to take -2 plus 3i, and you're going to multiply that by 1 plus 3i. So we have to go back to section 4 when we multiplied complex numbers together. So we're going to have to FOIL, so it's -2 minus 6i plus 3i plus 9i squared. So I just want to double check that I've copied everything right. So that's -2. This is a minus 6i plus 3i plus 9i squared. So let's combine like terms. This is -3i. This is minus 9. It says minus 11. So when I multiply, this is minus 11 minus 3i. So now you got to add that column. So you get -5 minus 3i. And now you have to multiply again. Just like we do with regular numbers, we are just having to deal with complex numbers here. So I take -5 minus 3i times 1 plus 3i again. So when I multiply that, I get -5 minus 15i minus 3i, and then minus 9i squared again. So when I put those together, what's that? -18i. This is positive 9 because of the -9 and then the I squared. So it's positive 9. So that ends up being 4. So this is 4 minus 18i. Add that column together, you're going to get 6 minus 18i. And now we got to multiply again. So I am running out a little bit of a space issue here. So hopefully I can squeeze some of this stuff in here. So I need to take 6 minus 18i times 1 plus 3i. When I do that, I should get 6 plus 18i minus 18i. 18 times 3 is, let's see, 18 times 2 is 36. And then other 18 is what, plus 54? I guess it's minus 54i squared. Yep. So now what happens to the 18i's? They cancel. Maybe I should put this off to the side. There we go. So this is canceling out. What's -54i squared? Well, that's positive 54, and a 6 is a 60. And lo and behold, what happens? I got no remainder. If I get a remainder, I have screwed up. Because they told us that this is a 0. So it's a given. We're not trying to prove that it is. We know that it is. They told us. So now what you need to do is take what you have. I'm going to recopy it. I'm also recopying it so I can drop the 0. I don't want to mess around with that anymore, leaving it there. So what else did I say a 0 was? 1 minus 3i. So let's, that's not going to work. I need to make it straighter so I have better space to write. That's a little better. So I'm going to bring my 1 down. This should be a little bit easier mathematically. We had a lot of foiling to do over here. Multiply. What happens to the i's? They cancel, and you get a -1. So then multiply this times that. What do you get? -1 plus 3i. What happens to the i's? They cancel. You get -6. And then you multiply -6 times that. You get -6 plus 18i. And hopefully you get another 0 there. If you don't, probably messed up. Okay? So what do we got left? Well, we got x squared. How do I know it's x squared? Well, we started with x to the 4th. You divided, got an answer, then divided again. So you've divided it by x twice, if you want to think of it that way. So it's x squared minus x minus 6, and then you have no remainder. So with this, it's possible that you have to use quadratic formula, but I am pretty sure that it can be factored. So if it factors, I'd rather do that. So it's x and x. What multiplies to 6? 6 and 1, 2 and 3. They have to add or subtract to 1. So it's got to be 2 and 3, 3 and 2. Signs are different. Bigger one's negative. So it has to factor into this. Solve these. 3 and -2 are zeros. And also 1 minus 3i, 1 plus 3i. So those are your 4 zeros. All right, so those are your problems, or your solutions, I should say. All right, so now it says write the polynomial as a list of linear factors, and list all the zeros. So our answer is going to have a bunch of parentheses, should have 5 zeros, 5 factors, because here's x to the 5th. And notice they didn't give us anything. So this is where we would either use our rational zero test and do some guess and check, or we could use our calculator and find the zeros. That's what we're going to do. So I go to the calculator, and I already have a pre-typed in. X to the 5th plus x cubed plus 2x squared minus 12x plus 8. Always double check to make sure that all your signs are correct. X to the 5th plus x cubed plus 2x squared minus 12x plus 8. Is that what I have? Yes. So we will graph that. And there's what our answer is. So we need to find this point and then this point. And if you recall, this is at least a double root because it's sitting on the x-axis. It looks like it's -2 and 1 are my solutions. But we will verify. And we do that by going second calc. And we're looking for the zeros. So it doesn't matter which two you find first. Let's go left bound here. Right bound here. And then we'll guess near the point. That is essentially 1. So it's 1, 0. And it's at least a double root. I don't know exactly how many it is, but I will go to my notes here. So from my calculator, I know that x equals 1, and it could happen more. So I need to be prepared that it's at least twice. It could be 3 or 4. It's not going to be 5 times because from my graph, I can see there is another different answer. So I got to go back to my calculator and I got to go second calc and I got to select 0 and then I got to do the left bound, right bound thing again. So there's my cursor. I got to go to the left, hit enter. How do I know I'm to the left? I know I'm below, but I also know I'm to the left. And I got to guess near the point, and it's -2, 0. And that's what we thought it was. We weren't 100% sure, but we always have to do that just to check. So these could be additional 1s, but I'm going to have to verify that. I can't just say it's 1, 1, 1, 1, and -2. I got to go through and verify these. So it doesn't matter which one you put in the box first. Let's put in 1 in the box. And then we're going to do 1. There is no x to the 4th, so that's 0. There is an x cubed. So that's a 1. There's an x squared, that's 2. There's an x, which is negative 12. And then there is a constant. It's 8. So we put 1 in the box. Bring down this one. We multiply. Add that column. We multiply. We add that column. We multiply. We add that column. We multiply. Add that column. And then we multiply. And lo and behold, we get a remainder of 0, which that means that it is a factor. So now we have x to the 4th because we divided x to the 5th by, by x. So I'm going to slide over here to give myself a little bit more space. So I'm going to recopy, but I'm also going to put the, excuse me, the second one in the box. So this one is in the box. 1, 1, 2, 4, negative 8. Do not start over. When I say don't start over, don't go back to the original equation. Go with what you've divided. So bring down your 1, multiply, add the column, multiply, add the column, multiply, add the column, and multiply. And lo and behold, got a result, a remainder of 0. So last thing we're going to do here with negative 2, we're going to put it in the box. And then we have a 1, a 2, a 4, and an 8. Don't go back to the beginning and start over. Bring down your 1, multiply. What's that, negative 2? Add, multiply, multiply, add. Again, I got a remainder of 0. That confirms that all 3 of these that I found on my calculator are zeros. So what do I got left? So I started with x to the 5th. I divided by x. I divided by x. And I divided by x. So I should have x squared, no x's, plus 4. So I got to solve that. We'll set it equal to 0. If you can factor, factor. If you can't, quadratic formula. I don't necessarily need to factor it, but I'm going to solve it by setting it equal to 0. And then I move the 4 over by subtracting. And then this is a square root. So I'm going to have x equals plus or minus 2i. Okay? So I have all my zeros. So I'm supposed to list them as linear factors. And I'm supposed to list them as all the zeros. So the zeros are, I'm going to come over here and list my zeros. My zeros are 1, 1. So that's a double root. 1, 1, negative 2, and plus or minus 2i. 2i is not a double root because it's positive and negative. So writing this as linear factors, it's kind of like working backwards now since I found my zeros first. It's x minus 1, x minus 1, x plus 2, and then x minus 2i, x plus 2i. Those are all my linear factors. Notice they're x to the 1st power. Everything is broken down all the way it could be. And so that is the polynomial written as linear factors along with its zeros. So that I need both pieces there because that's what they asked for. Some other question might not ask for it. So a lot of work on some of these questions, but keep in mind we're allowed to use our calculator. It is much easier than it maybe used to be. Prior to that, we would have had to find all 3 of these numbers, the 1, 1, and negative 2, by just guessing and checking, which that could have been a lot with an 8. So could have been more, could have been worse. So if you have questions, let me know. And good